Hi, I'm Tom. I want to talk about some ideas behind the database I'm paid to work on full-time, Convex. Convex is an OLTP reactive relational database where the queries are code. And I got to clarify, because SQL's code too, but I'm talking about procedural code. The queries are TypeScript. Procedural code looks like this Ruby function. I remember mostly enjoying writing web apps in Ruby. I had an expressive language for my business logic. I had a debugger and a profiler and a REPL. I used third-party gems, which is what Ruby calls libraries, for logging and testing. And I was coming from Python, so I didn't even miss static types yet. I couldn't talk directly to the database with Ruby, but there was an ORM that constructed SQL and converted the types back and forth. Now what this code's really doing is constructing SQL, sending it into the database, getting a response back, running some Ruby code, sending in the next SQL query, and there's a transaction open this whole time. Now, holding open transactions like this means there's more contention on the database. And the transaction's lasting longer than we really need it to. But the backend is the only place we can run this procedural language to describe our business logic, and so we have to go back and forth from backend to database, backend to database. And gosh, it'd be nice if we could just bring those closer together. And we can. We can run our procedural language right in the database. It's called a stored procedure. Here's that bank transfer in PLPG SQL. It's way more efficient, stored directly in the database, run directly in the database, a one-shot transaction. It's an interesting language. I hope it has closures. Oh, we've lost our ecosystem. Logging and debugging and profiling are all different. And our gems, our beautiful gems, how do we use them? I wish we could just write this code in Ruby. And you can, well, with Python at least. Here's PL Python. The interop could be better than building strings, but Python has ORMs too. So Convex is a database designed to have the best stored procedures possible. It's a fun design challenge, right? Let's see, I'd like to be able to use whatever procedural language we choose, not only in transactions, but also constraints and triggers. It'd be great if we had good interop between that language and SQL, right? I'd like to be able to ideally intersperse it. But it's hard to have good static types when you're interoping with SQL, which has pretty loose types. Now, for a query planner to still be able to optimize the execution of this language, it should be very constrained, but also very expressive. And what if I had a little lambda that I wanted to pass into a where clause? We can have query optimizer hints that double as doc strings, and that way, or gosh, it could be a closure in that where clause, and then everywhere the closure went, the state would be sure to go. Data flow. Maybe componentized, where you can pass it from one language into the other. Directives at the top of the files, like use SQL, use Python, embedded in Python, embedded in SQL, embedded in Python with some pandas in there too. But before I joined Convex, it had already been decided to use TypeScript as the procedural programming language, which I think is a great choice. It's a very popular language, lots of libraries for it, right? And it's a very common language for a web developer to know. And it turns out if you are writing an OLTP database, web is a pretty good application for it. But infrastructure-wise, it's a good decision too, because you can build a V8-based runtime that will, in an isolated way, run those transactions separate from the database. And then V8 runs WebAssembly too, so we can compile to WebAssembly until we go build the cooler WebAssembly-based runtime. But the interesting piece here is the approach to interop with SQL, which, after trying some of the traditional approaches and finding the type conversion kind of messy, is just don't do it. Here's a query in Convex, and you can absolutely see the spot where you would imagine we're compiling some SQL, right? Query looks like some kind of query builder, and then we're going to collect, which must mean execute, right? But actually, this is a call from the V8-based runtime into a native binding written in Rust that reads from storage. At no point is SQL constructed. A schema in Convex defines tables with specific JSON-like types and indexes on those tables. This is what it looks like to walk one of the tables. This is what it looks like to walk one of those indexes. With this approach, you can have a schema that defines types which flow through out to functions that read from those tables all the way to the external API of those functions. But there's another type of static analysis that we're losing out on here. And that's that a query compiler can't rewrite your procedural code. When you do a join in Convex, it's entirely in user space. You walk over the rows of one table and do an async map to fetch the other rows based on your join key. Now, there are many ways to do a join, but you're stuck with whichever one you write. Now, you don't have to write that code each time. You can use abstraction. You're in a programming language. You can use functions. You can use a bunch of TypeScript generics to describe this in a very abstract way and have a whole ORM library for it. And even when you use that library, you will know whether there is an index on your join key because index use in Convex is always explicit. But there's some heartache to breaking up with your query planner. You don't get to look at a join and say, that's going to be fast. I don't know how, but it's going to be fast. Instead, you add an index, you explicitly use the index, and for OLTP queries, that's often enough. All right, if we can't rewrite our queries, can we at least analyze them enough to know what locks to take out? We're going to need to run these things concurrently and efficiently. Let's see, in this one, I guess I could walk the AST and find the string literal messages inside of a query call. Sure. How about this? Same thing. I'd find both. Maybe I'll use both of them. Maybe I could compile it both ways and try to evaluate some of this code. Then I get to something like this, where I'm querying the database to store a value in the account variable, and then I'm switching on that. And sometimes I do one thing, sometimes I do another. But sometimes I await, on line 43, await some external function. And that thing's imported from some NPM library, and maybe I pass the capability to call any database function into there. No, I just can't analyze this. That could be 10 megabytes of inscrutable NPM stuff, right? People are running real logic in these functions. We can't analyze it enough. Here's our good old transfer transaction, but now in Convex. It's a mutation, which means it's a read-write transaction that's publicly accessible. Looks like it does some authentication stuff, and then it transfers the money. We pointed out that it's hard to analyze this, so what are our options? How can we go about serializably running this transaction concurrently with other transactions in the database? Well, All right, so when we run our transfer function, we first get a timestamp from a timestamp oracle and get a function runner to spin up a V8 isolate, hopefully one's already warm, and then we read from a snapshot at timestamp 1, 2, 3. Now, one of the things we read from that is the code. It's also stored in the database. Great, and how are we looking things up in this table? Well, actually, there's a transaction log, and things can change over time. I'm describing MVCC, right? There's different values at different points in time. You can read from those older snapshots if you want. So we read checking, it's 100. We read savings, it's 2,000 it looks like. And then we have some proposed writes along with a read set that we used to get those writes and the time at which we read those. We submit that to our committer, and it says, yeah, sure, I see no other transactions that have modified the things that you have read in that time. Now, what if it didn't work? What if there had been a write to one of those things that we read in between our snapshot and when we tried to commit? Well, it's time to retry. Well, if you're going to retry things, then you better not have side effects. So this is JavaScript, but it can't do anything. Or you can include any code in it, but it is limited in if you try to fetch, that's going to fail at runtime. So what do you do if you need to send an email to say that the transaction went through? Well, one of your writes to the database can be scheduling another function to run later, and that's how we do durable execution. That thing can retry all it needs. Now, what about a read-only transaction? Obviously, it'd be good to cache that result if we can. But along with that cache entry, we're going to write down the read set so that we know when to invalidate that entry. Now, proactively, we can evict that entry from the cache when we know it's been invalidated. So now, in the next request, we'll need to rerun that query. But sometimes, in fact, usually, with Convex, it's a subscription to the query. The client is saying, I'd like to know the value of this query, and I'd like to know when it's invalidated. I want all of my queries to have new results at that new timestamp. And that's easy to add in here because it's the same machinery we were using to invalidate the cache. We just invalidate the cache and then also run all the queries that have been invalidated, and then at one timestamp, we can give consistent results back to the client. These live subscriptions are especially useful in reactive UI frameworks like React. Here's some React code where the useQuery hook is subscribing the app component to api.messages.list. We can find out what that is by command-clicking through and finding out, oh, it's just collecting every document in messages. Here's that React component with a list of messages. And now that we understand the reactivity, we can anticipate that when I change one of the things in the read set of that query, Thomas, we're going to see it update live. And code works the same way. It's also part of the read set of that cache entry. So if we come in here and change this, hit save, then we're going to bundle it up, send in those stored procedures, and we'll see the query update immediately. So in Convex, queries are code. Clients subscribe to the results of arbitrary functions. MVC, OCC, determinism, read sets. Stored procedures are great because business logic is easier to express in procedural code. If you plan your own query, you will understand your query plan. For OLTP, you want predictable queries, but keep your query planner for OLAP. Man, procedural code's great. Let me write that stuff everywhere. Try Convex or try applying these ideas to your own database.